Hello everyone. This video is part of a series where we are exploring Typescript's features with the help of a React application. Our main goal is to learn how to type our code in order to improve confidence, reduce the amount of bugs, and also increase velocity during development. In the previous video, we discussed class inheritance with the example of the animal, cat, dog, and pug classes. Now, we didn't mention one major downside of class extension, and this is the fact that I can only extend one class at a time. So let's have a look at this other diagram. In this diagram, I try to extend both the animal and the pet class from the cat class. Now, this is going to throw an error because in TypeScript, as well as in Java, if you're familiar with Java, we have the limitation, the restriction that we can extend only one class at a time. Now, this can lead to some very complex scenarios where we have a lot of classes extending multiple levels of different classes and a very complex hierarchical structure. And we definitely want to avoid that. Now, how do we do that? This is where interfaces come into play. So interfaces, remember here in the past that I said that a class extension or a class inheritance is a signature, let's say a behavior or an interpretation that the cat is an animal or is an animal, right? In the interface case, then I stop thinking in terms of is a relationships and I start to think in terms of has a relationships. So I say that the class cat is going to have a couple of behaviors, and this allows us to add several behaviors to my cat class and build different objects based on this very modular interfaces, right? So the interfaces here are very isolated. They define only one function and they can be used more than one interface per class. As you can see here, the interface simply defines the signature of the function, and that means the function name, or to be more precise, it's the function arguments. Here they are non-existent. So let's say the function arguments here, no arguments, and their type, as well as combined with the function return type here, void. Now, I want to make a quick parenthesis here, and this is really a matter of personal preference. You will find in most of the examples and most of the code out there with TypeScript, you'll find interfaces being used to define the shape of objects. To be fully honest, I don't really like this approach. And this is just because I think that type aliases are actually a more straightforward way of defining the shape of a certain object. So you will see me using types whenever we need to define the shape of an object in terms of attributes, of properties. And you will find me using interfaces whenever I need to define or whenever we need to define behaviors. Now, interfaces are going to be restricted to usage in classes, and also they can be used as, let's say, the type of a certain object that is expected as a parameter or so. But we will not use interfaces to define the shape of the object. For this, we will use types. So let's come to our editor and let's put this into practice. Here, I will define an interface, and I will say that this interface is going to be called eTeamBehavior. And the eTeamBehavior interface is going to define the signature for my eat method, like so. So I will just write a comment here. The signature is nothing more than the method's arguments and their types plus the method's return type, like so. So the no arguments whatsoever here is our method's arguments and their types, and the colon void, so the void is the method's return type. Let's maybe do a slightly different approach, and we could say that, well, whenever the entity is going to eat something, then we will receive a initial food amount, and that's going to be a number, and we want to return a number afterwards. So the idea here is that we will pass the food amount, even better than initial food amount. We just pass the food amount, and later on we will implement a function that is going to decrease this by 1 unit every time we eat. Okay, so now the method's signature is food amount of type number plus the return type of the method, number. We also want to implement the interface moving behavior, like so, and we'll say move, and this is going to be of type void, like it is in our file here. And now in our cat class, and here you see there is a slight difference because I changed the signature of the it method, so we will stick to the code that is implemented in our online playground. So here I'll say class cat implements, and here you see that the keyword changes from extends to implements. So it implements the eating behavior and the moving behavior, like so. And as soon as I add these two interfaces here, Typescript starts telling me, hold on, you haven't implemented the required methods eat and move. So please go ahead and do so. So let's start with the move method. There's going to be return a void, and here we will just say console.log, nope, still not moving, right? So cats don't like to move, so we'll say, I mean, okay, some of them like, but let's stick to stereotypes here. So whenever we call the move method from the cat class, or not from the cat class, but from any cat instance, we will simply console.log, nope, still not moving. Now let's try to implement the eat method, and we are not going to pass any parameter. And let's say console.log eating, right? Eating, like so. And as you can see, Typescript does not allow us to do so. Why doesn't it allow us to do so? Because in the interface we have defined a different signature. Here we need to pass a food amount. We need to comply to the signature, and the food amount needs to be of type number. And the function here, or the method, Typescript is still complaining because our return type is wrong, right? If I hover over here, you will see that the type food amount return type of void is not assignable to food amount number return number, right? Type void is not assignable to type number. So here I could type this as number to make it clear, or I can simply ignore this. And here if I say return 1, for example, then the error should go away. And that's because Typescript is able to infer the return type of this method here via type inference. And then it says, okay, if you are returning 1, then it's fine. Here I can also say return food amount -1, and Typescript is going to be happy, right? So because food amount is a number, every time I subtract a number from a number, I end up with a number. So we are complying with the function signature, with the method signature that was defined in our interface. So here I will just add number for clarity. That's optional, but I prefer to be clear about it, and everything should be working fine. Now if I want to create a new cat, I can do so by using the new keyword, and then I can say cat.eat, and I need to pass a certain amount, right? So here, once I press, or once I execute the code, I'll just print eating into the in the console, and then this 2 here is going to be subtracted by 1. If we want to see this, we can say let food amount equals to 2, and then we'll say food amount is equal to cat.eat food amount. Of course, this is not a good design, but just for us to see how this works. And I will then console.log food amount, and we should expect to see 1. Exactly. Great. Now, what is the main advantage of interfaces, and what is the main advantage of having such a such a structure to our code? Well, as it turns out, now I can implement functions that don't need to specifically require a cat. For example, if I want to say a certain function that is going to be function take pet for a walk, like so, and here I will say pet. If I type this as a cat, of course I cannot take a dog for a walk, right? So let's create a new class here, dog, which is going to implement a moving behavior. And we will say, okay, the dog is going to, well, it's not going to eat. Maybe the dog is a little bit fat, so it cannot eat for the moment. It can only move, right? So I'll say move void console.log exercising, like so, exercising, right? So now I say take pet for a walk, and I say that my pet is of type cat. So now I would say pet.walk or pet.move, and that's okay. I can still do so. So I'll say take pet for a walk with the cat object or the cat variable here. And once I execute the code, I have the expected output, nope, still not moving. However, if I were to create a new dog here and I wanted to pass the dog instead of the cat, then you see that I start having an error. And this is because the dog is not assignable to parameter of type cat, right? So even though we don't use the eat method within this function take pet for a walk, we are still requiring the argument that is being passed to be of type cat, which means that it has to have both the move and the eat methods. Now, by having modular interfaces, I can decompose this and I can say, okay, this function is really not interested whether the pet is a cat, is a dog, or is a fish. As long as the pet has a moving behavior, then everything is fine. I can go and take the pet for a walk. So now, as you can see, I can take both my dog for a walk and I can also take my cat for a walk. And this is, I believe, one of the main advantages of decomposing behaviors in terms of interfaces, not only in TypeScript, but in any object-oriented programming language. Now, if I execute the code, we will have the different console.logs because the implementation of the move method is different in both of these classes. Great. So that's it for this video. And if you want to receive notifications every time I upload a new video, make sure to subscribe to the channel and you will get a small reminder once a video is up on YouTube. Also, if you're interested in any topic in development, make sure to write it down in the comments and I'll take that into consideration when planning future series in the channel. If you see a topic that interests you, someone else commented with a topic that you also think is interesting, give it a thumbs up because I also take into consideration the popularity of certain topics. Okay? So in the next video, we will come back to our React application and we will start implementing all this theory and these many constructs that we have discussed over the last couple of videos. Thank you for your time and I'll see you in the next video. Bye bye.